So, full disclosure, you cannot photograph a black hole directly. None of us can. But the effects of a black hole existing somewhere is very much visible and very much detectable. That is what I managed to capture this time, and that is what I want to show you. It's very, very cool, so do stay tuned and continue watching this. I wasn't really aiming to photograph a black hole. I was photographing a wide field area in the Cygnus region in the Milky Way, using my RedCat 51 telescope, a 250mm refractor, and I was thinking of taking a picture of two Wolf Rayet stars, a really intense stars that throw out a lot of energy, creating this beautiful blue oxygen 3 bubble of gas around them, with a really red and warm hydrogen alpha, infrared hydrogen alpha gas as a backdrop. And I figured that would be like a really cool composition. That is what I captured, and I realized that there's a little bit something of interest in one of the areas of this photograph. At the edge of this photograph, I noticed something interesting. A bigger concentration of hydrogen gas together with interstellar dust, creating a really beautiful and interesting region that I figured may be worth photographing a little bit closer. After doing some research, I found out that this is called the Tulip Nebula, and it's a perfect frame for my TS1Y5, my mid-size refractor at 800mm, a perfect target for that one. So I took out my great and beautiful telescope that I really love and pointed that one towards that region and started collecting data. So after the course of about a few nights, maybe 3 or 4 nights, I managed to collect a total of 16 hours of data. Now, before I show you guys that image, I wanted to share a little bit of a story. When I was a little boy, like younger, much younger, I remember that there was a new black hole, the first black hole ever discovered, and it was around somewhere in the Cygnus region, the very same region that I photographed this time. But when I was a little kid, I always thought that the black hole was somewhere around this region over here. And looking back today, I think I was looking at the North America Nebula. It's kind of fuzzy when you look at it with your bare eyes on a dark location. So I think maybe I just put one and one together and used my imagination as a little kid and thought, okay, that's where the black hole is. But in reality, the black hole is somewhere around here, this area here, and it's exactly the same area that I photographed. It's just next to the Tulip Nebula. So, like I always do when I take an image and I create this final image, I usually just go online and start comparing. I'm trying to see, like, maybe a little bit of naive thought, but I'm trying to see, like, have I discovered something? Is there something new there? Is there something that I have photographed that nobody else has? It didn't really take too much time to realize that I was in the exact area that the black hole Cygnus X-1 is. So I was really excited, and I started to do my research on that one. Cygnus X-1 is actually a binary system. It's a black hole and a blue giant that rotates against one another, or rotate together. They're estimated to have about 20 solar masses each, makes the entire binary system like the mass of 40 of our suns, and they rotate at around 5 days. I think it takes 5 days for them to make a whole rotation, and they're actually pretty close to each other, about 20% of the distance of the Earth and the Sun. So the mass from the blue supergiant is being sucked in, so to say, into the black hole. So the black hole is constantly being fed by the material or the gas from the blue giant. And this is much like water that is being sucked into the drain, the hole of the drain. You get the gas that it starts rotating around the black hole, and that gas is being superheated by this rotation, and some of that energy is being thrown out as ionized gas perpendicular to this disk, so at 90 degrees. So if you have this disk right here, the gas or the ionized gas will be spewed out in the like 90 degrees direction. This is exactly this ionized gas that comes at almost the speed of light, with a lot of energy and a lot of force, and it actually pushes out the blue oxygen and the red hydrogen gas that I can photograph, and creates this bow shock, or this bubble, sort of say, of gas. And it's that bow shock that we can see in this image. You can clearly see that there's a bow here, like a bubble, and that comes from the ionized gas from this black hole. And what's really cool as well in this image is that I can actually photograph the blue giant. The blue giant is just a regular star, and I can photograph it, and it's this one over here. So imagine around this very star, or just next to this very star, is a black hole. A black hole that sucks out or feeds on that star and creates this ionized jet stream or bow shock that we can photograph, or that I can photograph. And it's actually believed to take about 5 billion years or something before the entire star is consumed by the black hole and the binary system will merge and be just a final, much bigger black hole. So do write that down in your calendars. Alright, so that's what I wanted to show you guys in this video. I do hope that you have enjoyed it, and if you have, do not forget to give this a like, and if you want to see more of my content, my photographs and my adventures, don't forget to subscribe. And as usual, if you have any feedback, comments or thoughts, do write them down in the comment section. Here are the two final images. Enjoy, and see you next time. Bye bye.